Hello everyone. Once again, I would like to welcome all the viewers and especially the class 10 students to this online class conducted by State Council of Science, Technology and Environment. So for today, I will continue my lecture on the same chapter that I did in the last class, and that is the name of the chapter is Area Related to Circles. So in the last class, I have discussed about the circumference and the area of a circle, and I've done some problems related to circumference and area of a circle. So for today, I'm going to discuss about sector and a segment of a circle. First, let us start with a sector of a circle. So by definition, a sector, the portion of the circular region enclosed by two radii and the corresponding arc is called a sector of the circle. So have a look at this diagram to understand the definition. So the definition it is, so here a circle of radius r, right? So I take this angle as theta and I mark here point C, point D, A and B. So look at the definition. It is the port of the sector. The portion of the circular region enclosed by two radii. Actually, these are the two radii of the two circles and the corresponding arc. Suppose this ACB is our corresponding arc. So this region OACBO will be the sector of the circle, right? And this angle theta is called the angle of the sector, right? But then, if you look at this diagram, we see that there are two sectors, right? This one and this one, and we name that two sectors as minor sector and major sector. So which one is the minor and which one is the major sector? So to understand that, I separate these two portions. So I get this part and this part, right? So have a look at this one. As you can see, this arc ACB is smaller as compared to this arc ADB. So this arc ACB will be the minor arc. So this region OACB is called the minor sector, right? And here this arc ADB is a major arc. So this region is called a major sector, right? So at some point you have to note here. Note whenever we write sector, we mean minor sector, right? Whenever we write a sector, we mean the minor sector. And to find the area of this sector, we have a formula. Area of a sector is given by theta by 360 degree into pi r squared. So this is the area of a sector or area of a minor sector. So let us do some problems related to this formula. So here is our first problem, and the problem is find the area of the sector of a circle of radius 8 cm and the angle at the center is 30 degree. So this is a circle and given radius r is 8 centimeter, and this angle theta is equal to 30 degree. So we have to find the area of this sector. We have to find the area of this shaded portion, right? And let's start with the solution. Given to us is given radius r is 8 centimeter and angle of the sector, which is theta, equal 30 degree, right? We have to find the area of the sector, which is given by theta by 360 degree into pi r square. So theta is known to us, which is 30 degree by 360 degree into pi is 22 by 7, and r is known to us, which is equal to 8. So 8 square, right? So 30 and 360 can cancel. You get here 1 and here 12, which is equal to 1 by 12 into 22 by 7 into 8 square. We can write as 8 into 8, right? So we divide here 12 by 4, which is equal to 3, and divide 8 by 4, which is equal to 2. We are left out with 22 into 2 into 8 divided by 3 into 7. So if you multiply these numbers, we get 3, 5, 2 and 3 into 7, 21, which is equal to 16 centimeter square. So this value is the area of the sector. So now I'm going to discuss about the segment of a circle, and let us have a look at the definition. A segment of a circle, and the portion of a circular region enclosed between a chord and the corresponding arc is called a segment of a circle. So to understand this definition, let us have a look at the circle in this diagram. So this is a circle. So here AB is a chord of a circle, right? And as you can see in the definition of a segment, it states that the portion of a circular region, I mean it is a part of the circle, enclosed between a chord. This is a chord and the corresponding arc. Suppose our corresponding arc is ACB. So this region ACBA will be the segment of a circle, right? So if you look at this diagram, you can see that there are two segments, this one and this one, right? And we name the two segments as minor segment and major segment. And how could we understand that, or how could we name that segment? Which part is a minor and which part is a major? So I will separate these two portions from each other. I get this part and this part, right? So as you can see here, this arc ACB is smaller as compared to the arc ADB, right? So this will be the minor segment, as ACB is the minor arc, and this will be the major segment, as ADB is the major r, right? And we have one formula to find the area of a segment, and we have to note one point. Note, whenever we write segment, we mean minor segment unless stated otherwise. So this is the important point that we should note, that whenever we write segment, we mean the minor segment, right? So, and the formula of finding the area of segment, is given by, right? First, let us note that to get the area of segment, we have to join this point to this extreme point of the chord. So let us join, right? And this point O to the extreme point of this chord, that is point B. And as you can see, this is the radius of circle denoted by R, and also this is the radius of the circle denoted by R. And we have an angle here, so we denote this angle as theta. And so the area of a segment is given by pi into theta by 360 degree minus sine theta by 2 into cos theta by 2 closing bracket into r square. This is the area of a segment. So let us do some problems related to this formula of area of a segment. So here is another problem. The chord AB of a circle of radius 14 cm makes angle of 60 degree at the center of the circle. Find the area of the minor segment of the circle. So have a look at this circle. This circle is of radius 14 cm, and these two radius make an angle theta, which is equal to 60 degree at this center, and this chord AB. And our problem is to find the area of the minor segment. We have to find the area of this shaded region. So let us start execution. Given radius of the circle is r equal 14 centimeter and angle at the center, which is theta, equal 60 degree. Now let's find out the area of the minor segment. Which is equal to pi into theta by 360 degree minus sin theta by 2 into cos theta by 2 into r square. So let us put all the values. Pi is 22 by 7 and theta is 60 degree by 360 degree minus sine 60 by 2 and cos 60 by 2 into r square, and r is 14, which is equal to 14 square. So 60 and 3 is 60, can cancel, which is equal to 1 by 6, right? And also we divide 6 by 2, we get 3, and we divide 22 by 2, we get 11. So left out with 11, 7 into 3, which is 21, minus sine 60 by 2, 60 divided by 2 is 30, sine 30, and also cos 30, and 14 square is 196. So 11 by 21 minus, and value of sine 30 is 1 by 2, and value of cos 30 is root 3 by 2 into 196. Let us multiply this number and this number. 11 by 21 into 196 minus 1 into root 3, we get root 3, 2 into 4 into 196. Here we divide by 7, we get 3, also here divide by 7, we get 28, and here divide by 4, we get 1, divide by 4, we get 49. So let me write here, we left out with, which is equal to 11 into 28 divided by 3 minus, let us put the value or the approximate value of root 3, which is 1.73 into 49, and if you multiply this number with this number, we get 308 divided by 3 minus, and if you multiply this and this, we get 84.77, and if you divide this number by this, we get 102.66 minus 84.77. So if you minus this, we get 17.89 centimeter square. So this is the value of the area of a minor segment, right? So we are done with this problem, and for today I will stop up till here, and I will be doing some more problems related to this chapter. That's all. Thank you.